Uh, Hello guys, welcome to my another video. So today I'm not just going to be solving questions, but then I want to explain a concept and concept of what concept of functions. So I know this one it seems to be like a challenging subject, but topic, but it is doable. So now let's define a function. What a function is. A function a function f is simply what? A function that maps real numbers to what? To real numbers. So this it means that you're gonna have real numbers, you put them into a given function, and you get out what? You get out a what? A real number. So this real number part, we consider it as what? A domain. And this one, we consider it what? A range. So when we talk about a domain, we talk about all possible values of x. Here we talk about all possible values of y. So remember, also in functions, we have different types of functions, and these functions are classified based on what? On a certain property. The first function that we all learn about from grade 8 or maybe from grade 7 is the linear function, of which is given by this. So types of functions. The first function that we have is called a linear function. It is a linear function, which is given by what? By the general formula mx plus c, of which this defines what? The gradient. It is a gradient or what? The slope of what? Of the function. This c is what? Is the y-intercept. Y-intercept is where the graph meets the what? The y-axis. That's where the graph meets the y-axis, because remember, functions are also defined on what? On Cartesian plane. So for you to find the gradient, you need to have 2 points on the graph. You need 2 points, of which is a, which is going to be defined by maybe x1, y1, and b, which is going to be defined as what? X2, and then y2. Then to get m, as long as you have 2 points, is going to be the same as what? Y2 minus y1, then x2 minus what? X1. Or it can be y1 minus what? Y2, or x1 minus what? X2. So what you need to know is that if you start with X2, under here you must also start with what? If you start with Y2, you must also start with what? With X2. So finding this, finding the equation of this straight line or a linear function is easy, especially when you are given what? Only 2 points. So for now, I want us to try to find the equation of this straight line when we are given a point A to be 0, 1, and the point B to be 1, 0. Then let's check. How can we find the equation of what? Of this straight line given 2 points? The first thing that we need to do is to do what? Is to find the gradient, of which this is the formula, of which if you're going to name A, this 0x coordinate of A, which is 0, is going to be your x1 and x2, x1 and y1, x2 and what? And y2. So to get the gradient, we're gonna, this is the formula. Remember, I said you're gonna define 2 as b and 1 as what? As a. Then now we're gonna have y2, of which is going to be what? 0 minus y1, of which is going to be what? 1 is the what? Is the y coordinate of a. And then the x coordinate of b is going to be 1, minus what? The x coordinate of A is going to be what? 0, of which this is the same as minus 1 over what? Over 1, of which the answer is just what? Minus 1. Then you come and write your equation because you now have what? M, of which it is the gradient. Now we have minus x plus c. Then to get the value of c, you can use any coordinates. From this, you can either use A or use B and substitute in the equation because you have the x value and the y value. Then let's use A. We'll say, let's substitute what? A, of which is 0 and 1. Then what is the y value of A? Is 1, of which the x value is what? 0 plus C. Then which means C is the same as what? This is just 0. C is the same as what? As 1. And then now we're going to have the equation as what? As this. Now, this is how we get what? The equation of what? Of the straight line. So now, I hope the concept about the straight line is good. So if you have any question about the straight line, you will also share on the comment. So now let's define another function that we call it what? A parabola. Let's talk about a parabola. A parabola, it is simply different from the linear function because this one we have different equations. There are different ways that you can do what you can obtain the equation of what of the parabola, and it has lot of aspects compared to what to the linear function. So having the parabola, the parabola equation is given by y a x plus p squared minus q, or it can be given as what? As r, where you have x minus x1, then x minus what? X2. Or it can also be given as what? Ax squared plus what? Bx minus c. So these are three different equations of what? Of the parabola. So sometimes you can have your equation like this, of which you can also transform it to what? You can transform it to this. Or sometimes you can also have what? You can have it in this form. You can also transform it to this. So what you need to know in order for you to be able to find the equation of the parabola, this is what you need. You need something that is called the y-intercept. The y-intercept, of which the y-intercept occurs when what? When x is 0. And you also need the x-intercept, of which this one, it also occurs when what? When y is 0. So what you simply do is that when you're given the parabola equation, you just simply what? You say, okay, for the y-intercept, you let x to be what? To be 0, you get what? You get the y-intercept. If you have this kind of situation and this one, but for this kind of equation, the y-intercept is simply the value of the value of c. Why? Because if you let x to be 0 on this one and this one, you will simply get y to be what? To be c. So in order for you to get the x-intercept, you simply let what? Y to be 0. Of which in this case, you'll be solving like what? It will be like more you are finding the what? The values of x. So for example, let's say you have maybe x squared plus 5x minus 6. This one, it is what? It is considered as the parabola. And another thing that maybe I forgot to explain about, you need the y-intercept and the x-intercept, and also the turning point, the TP, the turning point of which is called the turning point or the stationary point. So the turning point, the only way to get the turning point, if you have this, then the turning point in this case is just going to be P and what? And Q. If you have this equation, the turning point is just going to be P and Q. So if you have a situation like this, the turning point, the x coordinate is just going to be defined as what? As minus B to A. If you have this kind of equation where your A is just the coefficient of x squared, B is just the coefficient of x. And from this, after finding the x value of the turning point, you can come to the original equation and substitute to get what? The corresponding y value of the turning point. The turning point, it determines where your graph is heading. It's simply telling you that when you are from this point, your graph is going that side or it's going to be like this. So now let's check this situation. How can we find the x, the y-intercept? To find the y-intercept, we say the y-intercept occurs when x is what? Is 0. Then we just simply going to say what? Substitute this minus 6. And also, I told you that what? As long as you have this kind of equation, the y-intercept is just going to be what? The value of c, of which the value of c in this case is just minus 6. Then here we're going to get y to be what? To be minus 6. But we said the y-intercept, then this is going to be, remember, we said x is 0, then y is going to be what? Minus 6. And then now, let's try to get what? The x-intercept. The x-intercept occurs when y is 0. Then you come and put 0 here, you will get x squared plus 5x minus 6. Then of which this x squared plus 5x minus 6, you equate it to 0, you solve for the value of x. This is what you're going to get. You'll have x, and we have x equals to 0. So now, what you need to observe is that the value here is plus, and the value here what? And the sign here is negative. So which means you're going to have plus and negative. Just because as long as the sign of what? Of the coefficient of what? Of x is different from what? From the sign of the constant, then you're just going to have plus and minus. Then now you need to think of factors, that the values that when you multiply with what? Two values that when you multiply you get minus 6, and when you add you get what? Positive 5, of which now the factors, the two numbers that we multiply to get minus 6, and when we add we get 5, it's simply 6 and 1. So now you need to think, which one are you going to give as a positive, or which one are you going to give as a negative? That is going to be determined by the sign of what? Of the coefficient of x. If the sign of the coefficient of x is negative, you will give the negative value to what? To a bigger value. If the sign is positive, you will give the sign of positive to what? To a bigger value, of which we said we have 6 and 1. So which means 6 is going to do what? It's going to have what? The positive sign, while list 1 is going to have what? A negative sign. Then here we will have x equals to 1, or what? Or x equals to what? Minus 6, of which this is going to be 1 and 0, because remember we set y to be what? To be 0. And also here we're going to have what? We're going to have minus 6 and what? And 0. So this is how you find the intercept. Then to find the turning point, remember what I said? I said you're going to use what? You're going to use this formula, of which this formula is going to be like this. You're going to have minus b. What is your b? Your b in this case is just the coefficient of what? The coefficient of x, of which you're going to have 5 divided by 2. And then what is the coefficient of what? Of x squared is just 1. Then you're going to have 1. This is the x-intercept. I mean, the x coordinate of what? Of the turning point is just simply what? Negative 5 over 2. Then to get the corresponding y value, you're going to substitute what? You're going to substitute the x value in what? In the original equation, of which we'll have minus 5 over 2 squared plus 5 minus 5 over 2 squared minus 6. Of which from this, I believe after adding this, here you're going to get 25 over 4. Then here you're going to get minus what? Minus 25 over 2, then minus 6. Then if you punch this in a calculator, you will get the answer, of which is going to be easy. Of which, if you punch that, I believe you will get, let's punch this in a calculator and see what we're getting. It's 25 divided by 4 minus what? 25 divided by 2, then minus what? Minus 6, of which I'm getting negative 49 over 4, of which now the turning point is what? Minus 5 over 2 and negative 49 over what? Over 4. Simple as that. So guys, please remember, tomorrow here I'm just showing you how to find the features of the functions. Then tomorrow we will do what? We will sketch. So from here now, let's go to the next function. I hope you have seen how you can do what you can simply find the what the aspect of what of parabola. So now let's try to check the other type of function. The other type of function is called a hyperbola. A hyperbola. A hyperbola is generally given by this formula. So this one is quite different from what from the parabola and the linear function, simply because here we have something that are called asymptotes. Asymptote is simply what? Asymptote asymptote is what? Is where the graph don't touch. Where your graph won't touch, that is called the asymptote. And those points where your graph won't touch, you can simply get them from what? From the equation. Then here, the first asymptote, you're just gonna equate this to zero. You'll have 1 plus p equals to 0, which is going to be given as what? Minus p. And the other one is simply the value of q, of which you're gonna say y equals to what? Q. So you know that from this, your graph won't touch this. And your graph will also do what? Won't touch where x it is equals to minus p. So, so in this case, the other important aspect is what? Is the value of a. When the value of a is less than 0, then which means it's negative. This graph, as long as it is negative, is going to be found where? Is going to be found in the first, in the second quadrant. And also where is going to found in the what? In the second quadrant and also the fourth quadrant. Now, if the value of a is greater than 0, then which means the value of a is positive. You know that this graph is going to be found where? In the first quadrant. And also where? In the third quadrant. So you can be given an equation like this: 2 over x minus 1 plus 1. So if the question say find what? The asymptote, which means you know that you're going to have x minus 1 equals to 0. You say x equals to 1. You know that or x, this x, where x it is equals to 1, your graph is not going to touch. And this one, it is a special name. The special name is called what? A vertical asymptote. So this one is called a vertical asymptote. Or at least this one, I said this one is going to be y equals to 1. This one is called a horizontal. This one is called a horizontal asymptote. This is where the graph won't do what? Won't touch in the y-axis. And this is where the graph won't touch in what? In the x-axis. So remember now the value of a in this case is 2, of which is what? Is positive, is greater than 0. Then this tells you that this graph is going to be where? In the first quadrant and what? In the third quadrant. And the reason why you find it in the first quadrant is because the value of y and x are both positive. And here you're going to have positive values. And there is the other reason why you find it in the third quadrant is because the value of x and y are both negative. And negative and negatives gives you what? Positive. Yeah, like that. So tomorrow we will be graphing these graphs. So let's go to another function. The last one that I'm going to explain is going to be the exponential. Exponential. This one is simply called the exponential function because the variables are what? Are acting like exponent, while the constant are acting like what? Exponent of constant. So this is given by this. You're going to have a multiplied by b to the power maybe x plus what? Plus q. So in this case, the difference between those other graphs that we explained and what and the exponential is that the exponential only have the y asymptote, the horizontal asymptote, of which is what is q. So you know that already, as long as you are given what the equation of what of the exponential function like this, you know that the graph won't touch where you see q. So for example, if you have something like this 2x plus 2, so you know that your graph, your vertical asymptote is going to be y equals to 2. Your graph is not going to do what? It's not going to touch where it's not going to touch where x it is or where y it is equals to 2 in the horizontal asymptote. And something that you also need to know is that when you are drawing the line of the asymptote, you don't use a solid line. You use what? A dotted line. I will also explain that when you are going to do what? When we are going to graph tomorrow. So another important thing to explain is what? Is the value of b. Is the value of b? Yes. If the value of b is greater than 1, then this graph is what? It's increasing. It is an increasing graph. But if the value of b is less than 1, then this graph, it is what? It is a decreasing graph. Like that. So this is something that you need to know as well. Because remember, we have these graphs, they also have some other aspect of increasing and what? And decreasing. And it's also important for you to know when the graph increase and when the graph what? Decrease. So guys, please, I want to thank you for listening to my video, and please follow for more. And tomorrow we will solve and what? And possibly graph. So please don't forget to follow me on Facebook, and don't forget to follow me on TikTok. And I'll also be uploading more videos on what? On YouTube. Please, all these classes are for free, and I've also created a WhatsApp group. I'm going to post a group link where you can send questions, where you maybe you have problems, you will share with me and I will solve them for you for free. Guys, this is for free. Thank you.